Okay, so this is the first problem of today's contest. We have three contests, and in this problem, we are given that we have a string x of length n and a string s of length m. Now, n and m, like if you find the multiplication of these, it's less than 25. So, what you can do in each operation, you're allowed to have, like if x is a, b, a, you'll change x to like x plus x. You'll add x to the end of x. So it will become ABA and then again ABA. Similarly, this thing. So you have to find what are the minimum number of operations that you have to perform such that S will appear in X as a substring. So since the constraints are so low, you can try for this operation for 10 times. If you don't get answer for the first 10 times, then the answer simply doesn't exist. Because now your string will be at least of size 512. So let me.
Your voice is lagging a little bit.
Okay, is it lagging for everyone or is it lagging for only for some people? Is my voice lagging for everyone?
No, it's clear.
Okay, so you have a string s, and what you can do, like string x of size n. So you can do this 10 times, like x is equals to x plus x. And before doing this, for each operation, like try to check to find whether s appears in x or not. So you can do this in O of n. Like you have to do this in O of n. N is basically the size of x right now. So if you do this in O of n and you're doing this only 10 times, like each test case will nearly take like less than 10 to the power 3 operations. And there are only 10 to the power 4 test cases, right? So this can be solved in 10 to the power 7. Is it clear?
Yeah, but how did you reach to, means how did you calculate this 10, means up to 10 it
10
will
basically
be
after 10, if you
okay.
start from one character, after 10 operations, you will have something around 2 to the power 9 or 2 to the power 10, something like this. So 2 to the power 9, like it is almost around 500 or 1000 characters. So after that point, the character like which you're getting like in start and end, if you didn't get that earlier, it's because the initial string of like the s is of at max size 25 only, right? It cannot be more than 25. So if you didn't get that before these operations, you won't get it further. You can try writing characters like what will happen if you have x, y, z. You will get z, y, x. Then you will get x, y, z, z, y, x, and x, y, z, z, y, x. After this point, you'll keep getting like you keep writing this, you'll get x, x, y, right? Like here you got x, x, y. Again, you will get x, y, z, z like this. So if you didn't get after a point, it will become a pattern. So if you
Okay.
didn't get that, you won't get it. And the original string that you have to match is just of 25 characters. That's why. Like it was just a brute force.
Yeah.
So this is the solution that I'm taking n and m as input. Then I'm taking string a and b as input. Initially answer is -1. Then I'm doing this for the 10 times. If I'm not able to find b, like this is the inbuilt function. And if I'm not able to find b in a, then I'll come to this part. Otherwise, I'm able to find b in a. Then answer is equals to I, and I'll break it. Finally, I can print answer. Is it clear? Yes, no. Okay, so let's go to the next problem. So in the next problem, we have that there are 3 threadlets and a pair of scissors. In one operation, Decim chooses any threadlet and cuts it into 2 threadlets whose length is positive integer, and he cuts these threadlets like the length should be integer. So we have to find whether Decim can perform at most 3 operations like he after performing at most 3 operations, whether or not he'll be able to get the cutlets, like the final cutlets should have all the same size. So see, if you initially there are 3 cutlets of different length, let's say these are the lengths, and you have to do at max 3 operations. So let's say there is one case when you are performing these operations on all the 3. So if you're performing operations on all the 3, you divided this into xy, you divided this into alpha beta, and you divided this into ab. So eventually, if all of these have to be same, x should be equals to y should be, because you applied 3 operations, right? At max, you can apply only 3 operations. So x should be equals to y, should be equals to alpha, should be equals to beta, should be equals to a, should be equals to b. So in a way, x plus y is equals to alpha plus beta is equals to a plus b. So all these 3 strings have to be same only, then only you can apply all the 3 operations on all of the three threadlets. Otherwise, you are not applying these 3 operations on all the 3. You will be leaving one out. And which when we will you be leaving? You will be leaving only that threadlet which has the smallest length. Why? Because if you leave any other threadlet which is having more size, you already have a threadlet which is having less size, and you cannot decrease the threadlet size which you are leaving out. So basically, you leave one threadlet and you decrease the size of other remaining threadlets. So you can insert all the threadlets in a multiset. Each time you can cut the threadlet which is having the maximum size. And how will you cut it? Let's say this is the threadlet which is having the least size is of x. So you will cut it into such thing like x and y. So one part will always be x. So do 3 operations, and after 3 operations, just check if in your multiset you're having the threadlet of least size and maximum size same or not. If it is of same size, then your answer is yes. Otherwise, your answer is no. Is it clear? Yes, no? Or should I repeat this? Like, just insert all the 3 values in your multiset, and pick the maximum value, pick or remove the maximum value from your multiset, the maximum value from your multiset, and let's say the minimum value was x in your multiset. So this is the threadlet which is having the least size. So you will insert in your multiset, you'll insert x, comma, if let's say maximum size was let's say m, so m minus x. So basically you need this x, right? And the remaining part will be this only. This can be less than x also, you don't have to worry about it. Then after 3 operations, it is not possible to make all the threadlets of same size. Is it clear? And I have already discussed that case when you are performing all the 3 operations on all the 3 threadlets, like one operation on all of these. Is it clear? Yes, no? What about others? So let me show you the implementation. So this is the implementation. In this, I have first taken ABC as input. I've inserted all of those in my multiset. Then I'm doing 3 operations, but you don't have to do 3 operations in case the maximum value and the minimum value are already same. That is, all the threadlets are of same size. If they are not, find the pick out the maximum value, insert in your multiset. Multiset, like this is x basically, and this thing is maximum minus the minimum value, like the remaining thing. If after these 3 operations, the maximum and minimum are same, you will print yes, otherwise you'll print no. So I hope this is clear. Like here, the x is having different meaning than what I explained. X here is the maximum value. When I was explaining, I took x as the minimum value. So basically this x is the maximum value. So going to the next problem. Okay, so in this, we are given that there is a matrix of size n cross n, and basically if once we rotate it 90-degree, like first of all it should be a perfect square. And what is a perfect square? It is nothing but that it remains unchanged when we rotate it 90-degree. So first of all, see, let's suppose this is a matrix, and what you have to finally answer in this, you have to answer that how many characters need to be changed to make this a perfect square. And how will you change this character? Like if you want to make A as C, you will do 2 operations on A. Like each time it will get incremented by 1. So basically you have to minimize the number of operations. Like find the minimum number of operations required to make the matrix a square matrix, like a perfect matrix. What is it? A perfect matrix. Let's suppose here is one. Here is, let me write this down. Here is a character. Let's say here is a character 1, 2, 3, and 4. So basically what will happen when you rotate this 90 degree? If you rotate this 90 degree, you will notice that 1 will come here, 2 will come here, 3 will come here, and basically 4 will come here. So this is how your rotations will happen. And notice that your matrix, initial matrix, is of size n cross n. So you just have to, like, for each character, you have to find the 4 positions which are part of this rotation. Like this character will basically end up here, the next character, like this is a cycle, right? This character will end up here, the next character will end up here, the next character will end up here, and this character will end up here. So this is a cycle. Each cell is a part of one cycle. So you have to find all the 4 cells in that cycle. And let's say these are the cells in the cycle, A, B, B, D. So what do you think? What do you think these characters should be after? Like if you want this, if you want the matrix to be perfect, anyone? If these are the characters, see, eventually this A will come to in place of B, B will go in this place, this will go in this place, and this will go in this place. So first of all, if D is going in this place, the character which is here should also be D. Like you will find like all the characters should be equals to the maximum character, right? Yes, no. Are you getting this part? Like all the 4 characters that are here should be equals to the maximum character. So you have to do just this thing, that if there are 4 characters in this, like this cell, this cell, this cell, and this cell are part of a cycle, you find all the characters in this cycle, and all these 4 characters need to be same. Why? Because that
You can only increase the alphabet.
yes, this is also because we can only increase the characters, we cannot decrease them. So we can make B equals to D, we cannot make D equals to B. So we'll make first B equals to D, and then A equals to also D, and all of these B will be equals to D only. So all the 4 characters which are appearing in these positions need to be eventually be equal. So they should be equals to the maximum character. And why should they be same? Because after rotation, let's say if any character is different, then let's say if we are having a C here and something other than here, like D here. So there's a conflict, right? Earlier it was a C, after it is a D. Afterwards it's a D. What is that? Is it clear?
Yes, but how will we find this cycle
so this is just
through
simple
code?
math.
Can you just
Yes. So
explain the code?
yes,
How you will
correct.
just detect this?
So since n, like you have a grid of size n cross n, and basically you just have to look at this part. Like these are the cells, and each of these cells in this part only you have to find what are the cells which this is part of. So this is basically ij. You have to find this I dash j dash, this is I double dash j double dash, and this is I triple dash j triple dash. So this is very like well-known problem. You'll find this in maybe in GFG and many platforms, that if you rotate this, how these cells actually go transform. Like this cell go here, this cell go here. For each of these cells, like this is for just for this cell. If you find for other cell, like something like
Can you
this,
just name the problem or send the link for that?
like I don't have the link. You'll have to like you can write something like rotate matrix 90 degree. You'll find that link.
Okay.
Probably, like I know it is there. Like you can look how this is like this actually happens, and I can show you the code also. Like I have the code with me. Like, but anyway, no one is having doubt in this part, right? The implementation or the approach. Then I'll show the logic.
Yeah, it's understood.
Okay, you have understood this. So basically, this is the logic. So first take n as input, then take all the, like this is the grid matrix, and now this is just a vector to find, like for each, like I'm staying in the first left corner, like this part. I'll only start from these cells, these four cells. So this is what does this, like I is starting from 0, and the I is will be less than n by 2. J is starting from 0 and j is less than n by 2. So I'm only in that left upper corner, and for each of the current cells, I'm first clearing my vector, and now these are the four cells which are part of the cycle. So this is like just pure, like how will you get those four cells? Like how will you find those four cells? So after that, sort this. Why? Because eventually every character in this, these four cells will be equal to the maximum character which is among these four cells. So this is nothing but like iterating through this. V dot back is nothing but the maximum character, right? Because I've sorted it. And minus E. E is nothing but the current character. So add each of these results to your answer, and finally you can print an answer. Is it clear?
So can you just explain the coordinates? Uh,
Which
this
part?
these four
Okay,
pushbacks.
this is like this four pushback is nothing but like the first cell is this, and now the next cell will be, like you have to, if this is ij, what will be the next cell? This is the next cell. So what is this? This is nothing but j my comma n minus I minus 1, n minus I minus 1, and this is true for every, if I and j are zero indexed. If this is your I, like if any cell is your ij, next cell will be j comma n minus I minus 1. If you rotate it 90 degree, this is the position to
But
which your cell will go.
how did you just read to this formula n minus
Like
j minus 1 like this?
I've done this many times, because like if you rotate it one time, it will go to j minus I j comma n minus I minus 1. If you rotate it 180 degree, then it will end up here. If you rotate it like 270 degree, it will
Okay.
end up here.
So that means I can remember it.
Yeah, you can remember it also, but I don't know, like when will you again find this kind of problem? Like it's better to, like you can visualize this also.
Okay. Okay. Okay.
Like what is
But
happening.
how are you visualizing it? Actually, I am not getting these formulas.
Yes, someone is saying something
Sir, where you increase the answer?
here.
Okay, sorry.
Okay, so should we go to the next problem? Yes, no, anything. What about others? Okay. So now this is the next problem. In this problem, we are given that there is an array A of n positive integers, and we can perform the following operations on it. So first, we have to choose a pair of elements AI and AJ, and choose one of the divisors of the integer AI, that is like any integer x which divides AI, and replace AI with AI by x, and multiply some AJ with this x. Finally, we have to find whether it's possible, after performing these some of these operations, we can have each and every element same. So look, what we are actually doing in this, we are taking something from AI, like a divisor of AI, or like something of divisor of AI, and we are distributing it, right? From here also we can take it and distribute it, right? Maybe let's say we took 6 from this, we can multiply 6 here, but again we can take 2 from here and multiply 2 here. So here we gave 3 and here we gave 2. So we took 3 and 2 from AI, and we divided AI with 3 and then with 2, and we gave 3 to this place and 2 to this place. This is what we are doing with those operations, right? Yes, no. Is it making sense? Is this thing making sense? Yes, no.
Yes.
Okay. So now eventually, see what you're doing. if let's say if 2 like 2 is occurring n times here, 3 is occurring 2n times here, like as a factor. 5 is occurring n times here and everything is 1. Can I not give this 5 because it's occurring n times? Can I not give each of these indices one of the 5s? Right? Can I not give each of these indices 2 3s? Yes. And can I not give each of these indices a 1 2? So everything will be same. But let's say 7 was occurring only 3 times. So I can give this 7 only to 3 places. I cannot give this 7 to each and every place, right? So basically, you just have to check. You have to first count for each AI. You have to count what are all the prime factors and how many times each prime factor is appearing in the prime factorization of AI. And then for all prime numbers, you just have to check whether or not each prime number is occurring multiple of, let's say, each prime number. What is how many times pth prime is occurring? And if it is not, if it is occurring as a multiple of n, then it's okay. Otherwise, it's not okay. Like each prime should occur as a multiple of n. Like 2 is occurring n times, 3 is occurring 2n times, 5 is occurring, let's say 5 is occurring here n minus 2 times, but 5 is occurring 2 times here. So again, I can give 5 to all the numbers, but I cannot give this 7 to all the numbers. Is it clear? So eventually, this is what you have to do. Is the approach clear?
Yes.
Now I'll move to
So
how to
means
do this.
we have to just calculate prime factors for each, and if they
Yes,
are
yes,
same, then
exactly,
add the
exactly.
powers and find
Yes.
whether it is there are multiple of n or not.
Yes, yes, yes. This is what you have to do. Now, how to do this? See, n over all the test cases doesn't exceed 10 to the power 4, and the numbers that you have, AI is basically less than 10 to the power 6. So what we can do, we can, like using square root method for finding prime factorization, we can find all the prime factors of AI in square root of AI. So this will take at max 10 to the power 3 operations, and 10 to the power 3 times 10 to the power 4 is 10 to the power 7, and it will pass. So just using for each AI, we'll in square root of AI time, we'll find the prime factors. We'll have a map or something. You can have an array also, but I have a map. So in that, you can count how many times each prime factor is appearing. And then finally, you just have to see whether or not each prime is appearing as a multiple of n or not. Is it clear? Count of this prime. Is it clear?
Yeah, it's clear.
Okay, so let me show you the implementation. This is the implementation. In this, I have first taken array A as input. Then this is basically the count, how many times each prime is appearing. So going through the elements in square root, like square root of E, I'm finding the prime factors of E, and I'm incrementing count for each factor. Then after this flag is nothing but like whether it's possible or not. So this is the prime factor and this is the number of times it's appearing. So I'm just doing flag and equals to y percentage n. Like this count should be divisible by n. If it is not, f will be 0. Finally, if f is 1, I can print yes, otherwise answer is no. Is it clear? Yes, no, anything?
Can you just explain this for loop? Means I have seen this first time. Auto of xy count
This
below
thing.
one.
Okay, this thing.
Even
This is
yeah, pair.
you don't actually have to, maybe you are not aware of map, so you can use something like count. You can make this a vector or an array and do the same thing and then iterate from 1 to maybe 10 to the power 6. No, you don't.
Can we do this with vector of pairs or only just map?
Like you, for that you'll have to also store like which primes are occurring here.
Yeah. No,
And then you have to iterate over
no.
that.
I'm just asking as general. Can we do this like
Like
auto of
you
xy
cannot
for
like
vector of
simply
pair?
brute force from 1 to 10 to the power 6, because then it will cause like TLE. You cannot simply, like you have to do, like if you want to do it, you'll have to do it smartly. You'll have to make another vector here, and in that vector you'll have to insert all the primes, and then over those primes you'll have to iterate.
Okay.
And this is just the condition, like if this is false, then this will also be false, like this will be 0. Simple bitwise operation. So let's go to the next problem. Is it clear? Yes, no?
Yes.
Okay. So the next problem is we are given a sequence, and this sequence is beautiful if it has a form of series of books, each starting with its length and then followed by those numbers. Let's say like this is beautiful. Why is it beautiful? Because see, first of all, this is a block and this is like another block. So this is the length of the block 1, and basically this complete thing. And this is another block, 4 is the length, and these are the elements. These are not beautiful. So you have in one operation you can remove any element, and you have to find the minimum number of elements operations required to make the given sequence beautiful. So now this is a very simple DP problem. So how to solve this? See, you have basically two things.
How did you reach to the conclusion that it is a DP?
Because I've solved problems like this earlier.
Okay.
So you have two things, like two options for this. Because first one is whether you want this to be part of a block or whether like you will start a block from here. So if you start a block from here, let's say this is AI. So this will have all the elements. Let's say AI is 3, this thing, right? So till this, how many operations, how many elements did you actually remove? None of the elements were removed in this part, right?
Yeah.
So the number of elements that were removed is nothing but the number of elements that were removed till this thing. So here dp of I is nothing but how many elements are you removing till this point. So dp of I is nothing but dp, not dp of I. This is not dp of I. This is dp of I plus ai. That element, right? So in this case, dp of I plus ai is nothing but minimum of dp of I plus ai, comma dp of I minus 1, because nothing was removed in this part, right? So you can take this to be this thing, same. Is this thing clear? Is this thing making sense?
Sir, can you just show means how what are the overlappings of problems here?
No, not overlapping. Just this
Because
thing. If you take this, if you have this as the starting point of your block, if you have this as your starting point of your block, then this will be the length of this block, right? This will be the length of elements, like the number of elements in this block, right? If
yeah,
this is 3, like this is my block, so this 3 is nothing but 3 elements are there in this block, right?
yeah,
So which all these are those elements x, y, and z, right? So if I choose this as my block, I'm not removing any elements from here to here, right?
yeah,
So dp of I is nothing but how many elements did I have to remove in order to have like only blocks till I, like how many blocks do I have to remove? So dp of ai plus I, ai plus I, this basically this index, I is currently this thing, I plus ai is this index. So dp of I plus ai is nothing but same as I minus 1. dp of like how many elements did I had to remove up till this point, because I didn't remove any element till this point, right? Like from here to here, I'm not removing anything, right? Is it making sense? So dp of a of I plus I is either minimum of this value or dp of I minus 1. Like the elements did you remove up till I minus 1, because this thing can be a block. Is it making sense? Yes, no?
Actually, I'm trying to find sub problems here, but I'm
Like
not getting
subprompt is
that
nothing but like
because the
see, if you look at I, there can be many blocks which can be like which at which you can end at, like I, which for which I can be the ending point. Basically, let's suppose if this is 2, 3, and 4. So out of all of these, you'll pick to end here, which is having the minimum dp of I value here. Are you understanding? So for each of these, you will do the same thing. When I is this, I is this, I is this, you will do the same thing. dp of I plus a of I is basically the minimum of dp of I plus ai, which is your this element. dp of I plus ai is this element for all of these i's, comma dp of I minus 1. Is it clear now?
Yeah, a little bit. I'll try it once again. Try run it once again, then it will be more clear. Okay. Okay. Okay.
Okay, basically this is this is the only transition that is going to take place here. And there is also one more thing. If you are not starting your current block from at the current ith place, then what you can do, dp of I is nothing but minimum of what it will be, dp of I or
I minus 1 plus AI. Oh,
dp of I minus 1 plus
AI.
not ai 1. You just need one operation to remove this element.
Yeah. Yeah.
Up till I minus 1, you have the blocks ready and you have the minimum number of elements that you have to remove. You remove this element also and you're good to go. Basically this thing. So let me show you the implementation. So this is the implementation. See, first we are taking n as input, then we are taking array a as input. Initially, I have initialized dp with 10 to the power 9. Now, dp of 0 is 1. Why? Because if you want, like you'll have to, like dp of 0 will always be 1 because you'll have to remove this element. If I'm looking in the prefix up till only first element, you have to remove this element if you want it to be a beautiful sequence. Why? Because it's never possible block of size 1, because the first element will be the number of elements and the next from next there will be the number of elements. Like you cannot have 0. The first element will be the number of elements, right? And then there will be these elements. So this is never 0. So that's why it's never possible to have a block of size 1. So you'll have to remove this element. So that's why dp of 0 is 1. Now, if a of 0 is less than n, why? Basically, dp of I plus ai. This is I plus ai, 0 plus ai. So if this is already more than n, then there is no point in doing this. But I don't think, like in the problem statement, yes, ai can be 10 till 10 to the power 6. Like it can be more than n also. So if a of 0 is less than n, this simply means I plus ai is less than n. So dp of 0 plus a of 0, that is I plus ai, is 0. Why is this? Because there is nothing as dp of I minus 1. You don't have to remove any element. This is basically, if you have 5 here, and these are the 5 elements. So 1, 2, 3, 4, 5. This will be dp of this will be 0. Why? Because you can take a block like this. You don't have to remove any element up till this point. Is it making sense? Why dp of 0 plus a of 0 is 0? Is it clear why is this 0? Because you don't have to remove any elements. Is it making sense? Yes, no?
For it to be 0, the last element should not.
Like the number of elements that you
Okay.
have to
Array
remove up
size
till
should
this
be
point.
larger.
Yeah, if let's say if you have only, like, how many elements do you have? You have, these are the indices. So 0, 1, 2, 3, 4, 5, 6. If you have 7 elements and this element was, let's say this was 10. So you cannot have this thing as 0 because this value is itself more than 0. So that's why
Yeah.
I'm checking if a of 0 is less than n.
Okay. Okay. Okay.
So if a of 0 is less than n, then dp of 0 plus a of 0 is 0. Otherwise, going from 1 to n, dp of I is minimum of dp of I minus 1 plus 1. That is, remove one element, remove the current element and take the value from dp of I minus 1 or dp of I. And if I plus ai is less than n, then dp of I plus ai is nothing but minimum of dp of I plus ai, comma dp of I minus 1. So I have already explained this, right? Finally, your answer is nothing but dp of n minus 1. Minimum number of elements to remove up till n minus 1. Is it clear? Is it clear? Yes, no, anything? Okay, in the chat. Okay, it's clear. So let's go to the next.
Sir, how do you write this in one go iterative code for DP?
Like this problem is a very simple variation of DP. Like I think
Okay.
it will be around 1300 or 1400, something like that.
Okay.
How did you get the recursive code for recursive?
Like recursive will be on same only. Like if you have to convert it to recursive, you'll have to like write solve of n, and it will return you up till like you'll start from n and you'll move to 0.
Okay.
Like, but this thing is, I think this thing is much more better. So in the next problem, we are given that we have a tree with n vertices, and some of the nodes or vertices are marked. And now let fi denote the maximum distance from vertex I to any other marked vertices. Let's like 1 is having the maximum distance as 2 because these two vertices are at distance 2. Similarly, 5 is having 3, like because not 3, 4, because these two vertices are at 4 distance. So we have to find the minimum value of fi, like for every vertex, like among all the vertices, what is the minimum value of fi? The fi is nothing but the maximum distance of vertex I from any other mark, like any marked vertices. So how to solve this problem? See, if you have something like this, let's say some vertices are marked. So first of all, for each vertex, just find the vertex, like the farthest vertex in its subtree. Vertex in its subtree. Can you find this in O of n? Like using a simple DFS, we can do this, right? Farthest vertex in every node subtree. Like what is the vertex which is farthest in its node subtree, which lies in this node subtree? Basically, the which is lowest marked. Each vertex, you have to find the lowest marked node in its subtree. Is it clear? Like how can you find this? This is a simple DFS. Like if this is marked, then lowest of this for this will be 0, and for each of the parent nodes you can do for for all the childs, like find lowest of parent is nothing but maximum of lowest of parent, and this is nothing but lowest of child plus 1, right? Using this thing you can simply find what is the lowest or the farthest vertex in every node subtree which is marked. Yes, no,
Means the
right?
height, no? Height of the tree, right?
No, it won't be height of the tree. Like for in this case, this is not having any node in its subtree which is marked. This is having 0, 1, not having anything, 2, 2, 1, 0, not having anything, not having anything. So these are the values. Like the lowest, how much below is the node which is having farthest, like which is having which is marked. Is it clear? Yes, no.
No, no.
Is it not clear?
What are you trying to say? Just
Like you said, height for this tree is 3.
yes.
So for this node, it is not 3, right?
Mm, for which root node?
What?
Which node? For which node?
For this node, the value is not 3, right? But the height is 3.
Yes, yes.
So that's why it's not height. And you said height, right?
Yeah, yeah, yeah.
So you get my point, right?
Yes, yes.
Okay, perfect. So is it clear to others also? Like, and you can calculate this, right? Using simple DFS, right? Yes, no.
Can you explain it once again?
Yes, I'll explain it once again. So basically, see, you have to calculate these values. These values are nothing but each node, what is like how much below this node is the like what is the lowest node in the current node subtree which is marked. So what we can do, see, if current node is marked, current node is marked, current node, let's say initially lowest for every node is having the value -1. This simply means that there is no node in current node subtree which is marked. Then if current node is marked, this is inside DFS. Like for when I'm having DFS, if current node is marked, lowest can be first made, lowest of for current node can be 0, right? Because at least this node is marked, right? Lowest of 0 means that the current node is marked. Is it making sense?
Yes.
Then I'll perform DFS, like something like for auto v, iterate through all the, like instead of v, let's write children. For auto, all the children of current node, which is u, and first perform DFS, which is this child node, and DFS on this child node. And then you can write something like lowest, if lowest of child node is not -1. What does this mean? That it is having some mark node in its subtree, right? If this is not -1, then I can do lowest of u is maximum of lowest of u, comma lowest of child plus 1. Because the node which was at this much distance from child node is now one more from this u node, which is parent of child. Is it clear? So after doing this thing, I'll have these values. Like instead of these stars, it will be -1. Is it clear? And this is like, make sure that you are not like considering like this has nothing to do with the height of the tree or the depth of this node or the height of this node. It has nothing to do with that. Is it clear?
Yes.
Yes.
Okay.
But in the question, we have to find the minimum of all the maximums.
Yes. And now once this thing, like this is just for every node, we know what is the farthest node from this thing. If we somehow get to know what is the farthest node from parent side, like from top also, we'll finally know for this node what is the farthest marked node, right? Farthest node which is marked, right? Node which is marked. And for if we know this, which is marked, if we know this for each and every node, we can pick the node which is having this as the least value. Basically, we have to minimize this thing only, right? And we already know what is the farthest node which is marked down the subtree. Like basically, we know in this part, but we don't know in this part. Like from this part, what is the node which is marked, which is farthest from this current node in this part? We know in this part, right? If we know from both the parts, like we will pick the farthest node, we'll pick the node which is farthest distant for each node, and we have to minimize that thing only. Yes, no. Let's say in this part it is x, like it is x distant apart. So let's say x is 2, basically this node is marked. And in this part, let's say it is y distant apart. So let's say y is 3. So 1 is this, 2 is this, 3 this is. So out of x and y, I'll pick the maximum, which is 3. So for this node, the farthest distant node which is marked is at distance 3. And basically I have to find this as the minimum value for among every node possible. So first of all, is the problem clear what we have to do and what we have already done? Yes, no. I'll write this again. So suppose I am at this node. I already know for this node what is the farthest node from this node, what is the lowest node from this node in this subtree, which is marked. If I somehow know from the parent also that what is the farthest node which is marked in this like in this region from this node, then I'll finally know what is the farthest node from this node, which is marked, right? And that is what I have to find for each node, because I can pick the minimum out of those, minimum distance, right? Yes, no.
Yes.
What about others? Is this thing making sense?
Yes, yes.
Okay. So now see, for the when I'm at, let's say I'm rooted at currently at some node, let's say 0 node. So for that, I simply can do that lowest thing only, because there is no parent for this node. But when I shift here, what I can do without considering this part, let's say this was having all these subtrees. So without considering this part, I can take the lowest node from this part and pass the node as +1, like that node +1 as a distance, right? Because let's say this is the node which is farthest. Without considering this part, that node is at 2 distance from this node, and from this node it will be 3. So then I can choose between 3 distant or the lowest distance of this node, lowest of this node, lowest of this node. I can choose the maximum of this. Is it making sense? If I do this thing, right? And I already have, for each of the nodes, I already have what is the lowest distant node. So I can easily calculate, if I don't consider this thing, I can easily calculate what is in the, like in this region, what is the lowest node, which is marked, right? Yes, no. What about others? Is it clear? So now it's just implementation. So how to implement this? I'll show you in the implementation only. So see, first I'm taking n and k as input. Then I'm marking each vertex. Like these are the these are the vertices which are marked. I'm marking them here, and it is basically 0 index. In the input, they were given to me as 1, starting from 1 index. Now this is, I'm taking tree as input. Now this is calculating the lowest vertex, which is marked in current node subtree. So this is a simple DFS. Then this is basically calculating answers. This DFS. This is second DFS, and in this initially answer is 1e9. For each vertex, first I'll create a multiset, insert something like which can like insert -1 or minus something, anything, such that I don't have to every time check like my multiset is having some size. So initially I'm just inserting something. Now this is the value that I got from top. Initially it was -1. So this is the value that I got from top. What is the farthest marked node? And I'll pick, you don't have to do this. So you'll pick the maximum of these two, the node that you got from above or the lowest marked node. And your answer will be minimum of your answer or this node. Basically, this is the farthest marked node from current node. If the current node is marked, then in your multiset, you can insert 0. Why? Because all the nodes in the subtree of node U can have this thing as one of the possibilities that is coming from top. Now for each of the vertices in the current subtree, insert every node's lowest marked +1, basically to have like this thing calculated when you are like not considering this set and you're considering all of these. So basically you're considering each of these nodes lowest marked +1. Why +1? Because basically making it this thing, like adding this 1h. So insert everything in your multiset, and then when you're shifting to the child nodes, first of all, check if the top m is not -1, then this temp is nothing but what will go right now to your child node as your top value. So if the top maximum is not -1, temp can be top maximum +1. Otherwise, if the current node is marked, temp will be maximum of temp or 1. The child node can have 1 from top, like one distant node, which is marked. Now, if lowest of v is not -1, then you'll remove this value. Basically, this value, the value that you inserted in your multiset. So you'll remove it and you'll pick if the multiset dot r begin, like if this value is not -1, that is there is some node in the, like this is having some node apart from this subtree, it is having some node which is marked. You'll take that node, like that much distance +1. Now why +1? +1 is basically for having this thing, like it was star mst.r begin distance was from this node, parent node, so +1 for this node. So basically that is why we are having +1 here. Now temp is basically the maximum distant node from this vth node which is not in its subtree, so you can send that as top m. So basically v is the next node, u is the parent node, and top m is this thing. Once you return from DFS, if you find that the lowest marked node was not equals to -1, you'll again have to insert it back into the multiset for node u. Finally, you can print your answer. So this is just like the implementation is like, I think I have over implemented it. You'll find like easier implementations also because there are around 1,000 submissions for this. But do you get the idea? Like what we are trying to achieve here? First, find the lowest for each node, like what is the farthest distance, and then somehow you have to also give that node the maximum distant node from its parent side, and you already have the maximum distant node which is marked in its subtree, and from parent you'll get the maximum distant node which is marked which is not in its subtree. Is that clear? Yes, no? Okay, you got it. So now the last problem. Yes, I think I have implemented it, like I have over implemented it, like there will be simpler implementations also. So going to this problem, like this is also a very easy problem. Like the idea is simple, that you have a string s, and basically a palindrome, you know what is a palindrome, right? A palindrome is a string which reads same from left to right and right to left. So a beautiful, like a string is beautiful if it does not contain any substring of size at least 2, which is a palindrome. Like a string of size 1 is always a palindrome, but a string is beautiful if it is not having any substring of size at least 2, which is a palindrome. So you have to perform two types of operations on string s, and those are, you have to like add x to range like substring l to r, and by adding you simply do, if it was like, let's say if you're adding something, if you're adding 5 to this, so first it will become b, then c, then d, then e, and then f. So this is first operation, second, third, fourth, fifth. So if you add 5 to a, it will become f simply, and then if you add 1 to z, it will become a. So this is how additions basically work. So now you just have to see if, like after adding, like you have to perform two kinds of operations, adding x to l to r and finding whether or not the substring l to r is beautiful or not. So basically there shouldn't be any palindrome in substring l to r, only looking at the substring l to r. So first of all, see, you just have to look for palindromes of size 2 and 3. If there is palindrome of anything which is bigger than this, like these two lengths, it will always contain a palindrome of these two lengths. Like any palindrome which is of length 7 also has a palindrome of length 3. Any palindrome which is of length 8 will always have a palindrome of length 2 at the center of it. So you just have to check for two things, that your current string shouldn't have a palindrome of length 2 or 3. Now how to solve this problem? See, initially, instead of a, b, c, let's take, instead of a, I'll take 0, b, I'll take as 1, c, I'll take as 2. Basically the ASCII, like not the ASCII codes, but instead of a, take 0, b as 1, c as 2, and like value as like these. Like just to make a vector so that we can have like range queries, like range additions on this. So you have x, y, z. So we can build a segment tree on this. Once you build your segment tree on this, if you get operations like 1, L, R, X, so basically you have to add from L to R, you have to add you have to add x in this range. And if you get 2 LR, you have to find whether or not there's like no palindrome of size 2 or 3 occurs in this range, right? So I'll come to this part in a moment, but first of all, can you do this thing? Like this is just create a vector or an array of size n, and like for 0, for A you will have 0, for B you will have 1, for C you'll have 2, and you can perform this range addition, right? Yes, no? Like, can you do this thing? Okay, like yeah, this is not covered in every level. Okay, but anyway, you can get the idea. So segment tree is nothing but like adding x to this range. You can use Fenwick tree also, by the way. So anyway, once you do this thing, see if you're adding, how will your size 2 palindrome or 3 palindrome will change. So if you add x to L to R, the palindrome, like this 2 length palindrome can change, this won't change. Why? Because both of these are getting added. If it was A and A earlier, then there will be something like D and D. But if it was C and C earlier, this thing got added, this will become D, but this will remain C. So you have to check for these two. You have to check, let's say this was your R. You have to check for these two. Then for three length string, so 3 length palindrome, you have to check for these, and you have to check for these. Similarly, you have to check for these, like because if earlier they were palindrome, like this string was palindrome, it won't be. Why? Because you added something to this, or you have to check for this thing, like this string from here to here. So these are the 6 things. Let me. So first, second, third, fourth, this is your R, right? And this is your L. So if you're doing an operation on L to R, these are the 6 strings, substrings that you have to check, which if in case they were palindrome earlier, they might not be. And once you add L to R, like X to this range, you can just again check whether or not these characters are same or not. If they are same, you can again like make sure that they are palindrome. If they are palindrome, you can either make another array which is having 1 in places. Let's say this is for palindrome of size 2. If I'm having 1 here, this simply means that there is a palindrome of size 2 here. If I'm having 1 here, this simply means that I'm having a palindrome of size 2 here. If I'm having a 1 here, this simply means that I'm having a palindrome of size 2 here. And also for size 3, if I'm having 1 and 1 here, this simply means this one means that this is a palindrome, and this one means that this is a palindrome. Finally, when you're given a query like 2LR, you can just find, first of all, in this array, what is the sum for L plus 1 to R. If there is any 1 in this range, then it simply means that you have a palindrome. So the answer is that your string is not a beautiful substring. Also, if in this subarray from L plus 2 to R, you get that you have at least 1, then no, again, no, you don't have a beautiful substring. Otherwise, you have a beautiful substring. If you don't want to use these 2 arrays, you can do something like use 2 multisets. And the idea of this is nothing but insert these in your 2 multisets, let's say these positions of ones, and just find lower bound and just check if lower bound of L plus 1 is more than R, then the answer is okay, you don't have a palindrome of size 2. And if the lower bound of L plus 2 is more than R, then again, you don't have a palindrome of size 3. So you can print yes. Otherwise, if any of these 2 checks fail, your answer is no. So is it clear? Okay, what about other guys level? Like, is it clear? Yes, no?
Can you show the code,
Yes,
please?
yes, I'll show you the code implementation. So this is the implementation. like I haven't shown the segment tree implementation because I have copied it like from GFG only. So like there is nothing to show in that. But this is the implementation, like the core logic part. I've taken n and m as input, then I've taken string s as input. So this is the array that I've built from initial string. Then I've initialized my segment tree. Then instead of using two arrays, I have used two sets. And PR2 is just storing the places at which my two length palindromes are ending, and PR3 is storing the positions in which three length palindrome are ending. This is just to make sure that lower bound doesn't give me like any of these ending iterators, like the ending point of these sets, like ending point iterators of these sets. Then for each of the queries, I'm taking L, R, and X as input. I'm decreasing L and R. So just check if L is more than 0, check L minus 1 and L. Simply check what is the value at this thing, modulo 26, because again, the characters like after Z you're getting A. So just check this thing. If earlier they were same, remove it from PR2. This position L. Do this for all the 6 substrings that I've just shown you. Update the range. You don't have to actually update this as 26. You can do it like this also. Add X to L to R. And again, for these 6 substrings, if any of those are palindromes, again update your sets. Finally, if you get a query like L to R to L to R, just check if the lower bound of L plus 1 is less than equals to R, then that means that you have a 2 length palindrome in range L to R. Or if this is true, then you have a 3 length palindrome in your range L to R. So you'll print no, otherwise you'll print yes. Is it clear? Yes, no, anything?
In the segment tree, are we storing the ASCII values or 0 or 1 characters?
No, not the ASCII values. Like initially, those are not ASCII values, but for A, it's 0, for B, it's 1.
Like, I mean, it is
Yes,
storing 0 to 26 or only 0 or 1?
from 0 to 26. And then you can just keep adding X. And when you're from segment tree, when you're like getting a value for an end, for some index, you have to take modulo 26. And then you'll get like the relative character, right? What it will be. It is the first character, second character, like that. Or the zeroth character is A. That's why I'm comparing these two. So is there any other doubt?
And can you please explain the case of 3 again? Like, I understood the case
Case of 3 is basically if, let's say this is your L, either your substring can be like this thing, this was a palindrome, it cannot like, it can like change, like it may not be palindrome after you added something to L to R, or this. Same is for R. When here is your R, you have like this or
like
this.
I mean ki why we are considering 3 like 2 is mentioned in the question ki
3, basically, if it is more than 2, it can be 3 also, right? Anything more than 2.
yes,
So a 5 length palindrome is not having any 2 length palindrome in it. But any palindrome will always have 2 or 3.
okay, got it. 2 or 3 only. Any palindrome will have 2 or 3.
Yes.
Okay.
So it's clear, right?
Yes, get it the idea.
Okay. So thanks for joining, and bye-bye.